Oh, before we continue, a very important thing to keep in mind, very important, is that if we are going to multiply two matrices, the amount of columns in the first must be equal to the amount of rows in the second matrix. Okay? So what does that mean? For example, if I have a matrix that was a 1 by 2, okay, and 1 by 2 means that it has one row and two columns, so it would look like this, one row and two columns. Then I can only multiply it by another matrix that is going to have two rows in it. It has to be equal to the amount of columns in the first. So it would have to be a 2 by something. It doesn't matter what it is. It could be a 2 by 1, 2 by 2, 2 by 8. It doesn't matter. But the amount of rows in this one, in the second one, has to be equal to the columns in the first. Now let me see if you get the idea. Does that mean that I could multiply a 2 by 1 matrix by a 1 by 3? Well, if we look at it, the columns in the first, which here would be 1, is equal to the rows in the second, which is also 1. Therefore, they could be multiplied. What about these two matrices? What if I had two matrices like this? I'm not going to tell you the order, but I want you to tell me if these two can be multiplied. Well, our first matrix, we notice that it has 2 rows and 2 columns. And our second matrix, so this would be a 2 by 2, and our second matrix has 1, 2, 3 rows and 1, 2 columns. So in this case, the amount of columns in the first, which is 2, is not equal to the amount of rows in the second. Therefore, they could not be multiplied. So that's a very important thing that we have to keep in mind when we're multiplying matrices. Let me just block that off right here. Now here's the main idea to multiply two matrices. We multiply the rows by the columns. Here's an easy way to help you lay it out. So let's see what it looks like. Let's say that I had two matrices M. M was 3, 5, and N was equal to 2, 1, let's say, right? And I wanted to multiply them. Now, the first thing we need to check is if the columns in the first is equal to the rows in the second. When I look at M, I see 2 rows and 1 column, so it's a 2 by 1 matrix, and N has 1 row and 2 columns, so it's a 1 by 2 matrix. Since the columns in the first is equal to the rows in the second, that means they can be multiplied. Now what we're going to do is that we're going to lay out our multiplication so it makes it a little easier for us. So first I'm going to put down M, as in literally I'm going to write it down here. Okay, just follow me so far. And then I'm going to do what I say, put up N. So it's like I'm going to put it up here. It's kind of like the size of a rectangle, really. And now I'm going to multiply the corresponding rows by columns to get the resulting entries. So let me start. To get the entry that's going to fall right here, I'm going to multiply this row by this column. And in that case, that would be 3 times 2, which is 6. To get the entry over here, I'm going to multiply this row by this column. So I'm basically, to get the entries, I'm multiplying the row by the column that it falls under. And when I do that, 3 times 1 would be 3. I have another entry down here. Another entry would be right here. So to get that entry, I'd multiply its row by its column. And that would be 5 times 2, which is 10. Likewise, to get the next entry, you can notice that I have one final entry right here. Then I'd multiply the row that it's in by the column that it falls under. So that's 5 times 1, which is 5. So therefore, the resulting matrix for Mn is going to be equal to 6, 3, 10, 5. And that's the basic idea. So we multiply the corresponding rows by the columns. Now let's do a harder one. Okay. Now let's say that I had two matrices, P and Q, and I want to multiply them. So let's apply the same idea. So I want to find PQ, and I'm going to put down P. So that's going to be 5, 2, 3, 1. And I'm going to put up Q, okay, which is 0, 4, 1, 2. And I want to find the matrix that results. So that means I want to find the matrix that would be right here. Now, as we said, we multiply the rows by the columns. So to figure out the entry that's going to be here, we need to multiply its row, which would be the row right here, times its column. But the thing about it is that you'll notice these rows have more than one entry, and so do the columns. Whenever that's the case, then we multiply the first entry in the row by the first entry in the column, the second in the row by the second in the column, and if there's a third one, the third in the row by the third in the column, and so on. And then we add them all up. So that means we're going to multiply the first entry 5 in the row by the first entry in the column 0, and the second entry in the row, which is 2, times the second entry in the column, which is 1. And then we just do that for the rest of our entries. So for our second entry, which would be this row by this column to get the entry that's right here, then we'd multiply 5 by 4, which is 20, and then add it to 2 times 2, which is 4. To get our entry down here, we have a row and a column right here, so that's going to be an entry, where this row will multiply this column. So that's going to be 3 times 0, which is 0, and 1 times 1, which is 1. And finally, we'll have an entry right here because it falls under a row and a column, where we're going to multiply this row by this column. Okay, so that's going to be 3 times 4, which is 12, and 1 times 2, which is 2. Now that we've multiplied our terms, or we've done the multiplication, then let's work it down. So 5 times 0 is 0, and 2 times 1 is 2. So that means the first entry is going to be 2. 20 plus 4 is 24. 0 plus 1 is 1, and 12 plus 2 is 14. Therefore, this is what PQ would work out to be.